This is Algebra 3, Prerequisite Chapter, Section 3, Polynomials and Special Products. One of the most common types of algebraic expressions is the polynomial. You have a few examples there. The first two are polynomials in x, because x is the variable. The final one is a polynomial in x and y. Okay, the terms, and let's remember that the terms of an expression are the parts that are separated by pluses and minuses. The terms of the polynomial in x have the form ax to the k. A is the coefficient. Remember, a coefficient is just the number that's in front of the x. K is the degree of the term. It's also the power. So, for example, 2x to the third minus 5x squared plus 1 has coefficients of 2, -5, 0, and 1. Now you may wonder why the 0. You'll notice we have an x to the third, an x squared, but there is no x term. The very next one doesn't have an x. So the coefficient on that x term would be 0, which is why you don't see it. It's not there. Here's the formal definition of a polynomial in x. Don't let all the numbers and the letters and the subscripts confuse you. A sub 0, A sub 1, A sub 2, those are all real numbers. Those are all the coefficients. It's just a way of designating that they can be different numbers. They don't have to all be the same. Again, notice the powers. We start with x to the n, then we go to x to the n minus 1. This again is indicating our powers, and it's showing that they're going to go down. So whatever your first power is, your next one is going to be one less than that, and so on until you get down to where you don't have an x at all. A sub n has to be not equal to 0. You have to have some kind of number out front, even if it's only 1. The degree of the entire polynomial is n. In other words, the degree of the polynomial is the same as the highest power on the variable that's in the polynomial. The leading coefficient is a sub n. That is the number in front of the variable with the highest power. If it's in descending order, which means we have our variables where the highest power comes first and it gradually goes down, if it's in that order, then our leading coefficient will actually be leading. It will actually be in the front. But if they're all mixed up, it may not be. So the leading coefficient is always the coefficient in front of the x with the highest power. And a sub 0 is the constant term. The constant term, remember, does not have a variable with it. Polynomials with 1, 2, or 3 terms have special names. They're called monomials, binomials, and trinomials. And like I just said, when the powers of x go down, start at the highest and go down, this is called standard form. It's also called descending order. Okay, let's try this example. You're going to write the polynomial in standard form, state the degree, and the leading coefficient. Pause this recording, try the problem, and then resume to check your answer. Here are our answers. Notice on A, we had to rearrange it and put the -5x to the 7th up front. Notice that the minus sign goes with the term that it's in front of. So it doesn't just stay in place. When we move the 5x to the 7th, the minus has to come in front with it. The degree is 7 because that's the highest power, and the leading coefficient is -5. For B, again, notice the negative comes with the 9 into the front. So it's -9x squared plus 4. The degree is 2. That's the highest power, and the leading coefficient is -9. I know C doesn't really look like a polynomial, but even though it's only one term, it is considered a polynomial. The standard form, it's just written as 8. Technically, you could write it as 8x to the 0 if you want to put the x in there. The degree is 0. When there is no variable, when you have a constant term, the degree is 0. And the leading coefficient is 8 because that's the only number that's there. Okay, if you have a polynomial that's just 0, it has all 0 coefficients, then it's called the 0 polynomial. There is no degree assigned to the 0 polynomial. So if they ask you for the degree of 0, it has none. The reason is that x, the power in x could really be anything. Since you're multiplying it by 0, you end up with 0. Okay, for polynomials in more than one variable, the degree of a term is the sum of the exponents of the variables in that term. And then the degree of the polynomial is the highest degree of all the terms. So for example, if you look at the polynomial there at the bottom of the notes, in the first term we have an x to the third and a y to the sixth. Add those powers together. 3 plus 6 is 9. So the degree of that term is 9. 4xy. X to the first, y to the first, 1 plus 1 is 2. So the degree of that term is 2. And then the last term, x to the seventh, y to the fourth. 7 plus 4 is 11. The degree of that term is 11. That is the highest degree, so that is the degree of the entire polynomial. And the leading coefficient of the polynomial is going to be the coefficient in front of the highest degree term. So for the one we just did, the number in front of that final one would be your degree. Expressions are not polynomials when a variable is underneath a radical or when a polynomial expression is in the denominator of the term. So just because you've got variables and powers doesn't mean you have a polynomial. Some examples, x to the third minus the square root of 3x. Okay, that is not a polynomial. It's underneath a radical, or another way of looking at it is, yeah, it has a power, but it's a fraction. Fractional powers are not allowed in polynomials, so that's not a polynomial. The second one, we have an x in the denominator, or with a negative power. You can't have that in a polynomial either. So the powers must be whole numbers. They cannot be negative. They cannot be fractions. They can be 0, but you cannot have negatives or fractions. You can add and subtract polynomials the same way you add and subtract real numbers. What you need to do is you need to combine the like terms. You've done this since you started Algebra 1. This should not be a big deal. How you combine like terms is by adding or subtracting the coefficients. So for example, negative 3xy squared and 5xy squared are like terms. When you add them together, you're really just adding the negative 3 and the 5, and your answer will be 2xy squared. Here are a couple examples of combining polynomials. Pause this recording, try the problems yourself, and then resume to check your answer. Here are the answers, actually the work spelled out for you. What they did was they grouped the like terms first and then combined them. Check over the answers if you need to. Pause the recording again to make sure you got it right. And if you made a mistake, see if you can find your mistake and correct it. When you're ready to move on, resume the recording. Now multiplying polynomials is going to be a little bit different. What you're going to do is you're going to use the left and right distributive properties. What you'll do is you treat 5x plus 7 as a single quantity, and then you multiply 3x minus 2 by 5x plus 7. If you look at the screen, it shows you how that works. The 5x plus 7 gets multiplied by 3x. It also gets multiplied by negative 2, and then you use the distributive property, 3x times 5x plus 3x times 7 minus 2 times 5x minus 2 times 7. And then you simplify. This is actually a way of showing you why FOIL works. You've learned FOIL before. It's when you multiply the first, the outer, the inner, and the last. This actually shows you why FOIL works. So whether you do it the way that it's spelled out here or you use FOIL, you should get the same answer, 15x squared plus 11x minus 14. We do have a few special products, and the good news is that you don't really need to memorize the patterns on these necessarily, although it can really make your life easier. You can multiply them out if you want to. So if you look over these should be familiar to you again. When you multiply u plus v times u minus v, you need to FOIL it out. You'll notice that the middle term disappears. You have u squared minus v squared. Please look over these, the square of a binomial and the cube of a binomial. Pause the recording if you need to. Move on when you're ready. For this example, you're going to multiply 5x plus 9 times 5x minus 9. Try the problem, pause the recording to do that, and then resume the recording for your answer. Okay, this is showing you how the problem works out. It's actually referring back to the rule, which you can do, or you can actually multiply it out if you need to. If you multiply it all the way out, you're going to get 25x squared plus 45x minus 45x minus 81. The plus 45 and minus 45 in the middle cancel each other out. And one final example, a word problem, because I know you love them so much. We have an open box that's made by cutting squares from the corners of a piece of metal that is 16 by 20 inches. And it's shown there for you, and they actually give you the dimensions, which is really nice. You don't have to reason out what the different sides are going to be. The edge of each cutout square is x inches. Find the volume of the box in terms of x. Then find the volume of the box when x is 1, 2, and 3. So what you want to do is find a general formula for the volume. And then once you have that, you can substitute each of those numbers in individually. Let me remind you that the volume of a box, and by the way, if you look at the lower picture, it shows you the box put together with the dimensions. The volume of a box is length times width times height. Pause this recording. Try the problem, and then resume the recording to check your answer. Okay, there's our general formula for the volume. You can see how they multiplied everything together. And 320x minus 72x squared plus 4x to the third. Notice you choose two of the things that are being multiplied. You do them first, and then multiply that answer times the third. And then you have the answers for 1, 2, and 3 inches. Okay, check your answers. If you made a mistake, see if you can figure out where your mistake is. And I believe this is the end of this section.